Hello everyone, welcome to the solution of LeetCode problem 1926 named nearest exit from entrance in maze. In this problem, we are given a m by n dimension maze, 0 indexed, with empty cells which represent 0 or dot and wall which represents plus. Now, you are also given an entrance in the maze where it is a coordinates x and y. Denotes that the number of rows and columns of the cell you are initially standing at. Now, in one step, you can move one cell up, down, right, or left. Now, you cannot step into a cell with a wall and you cannot step outside the maze. Your goal is to find the nearest exit from the entrance. And here, an exit is defined as the empty cell where it is in the border of the maze. And the entrance does not count as an exit. Now we have to return the number of steps in the shortest path from the entrance to the nearest exit, or we have to return -1 if no such path exists. We are given the first example. Here, these are the walls, which is the red marked, and I am standing here. Now, in one move, I can go 1 unit up and reach here, or in 2 moves, I can go 2 unit left and reached here. Now, in both of the scenarios, I will be standing in an empty cell, which is situated in the border. So what is the minimum? The minimum number of moves is 1. That means the optimal strategy is I can move 1 unit up and reach the border cell. So that's why we have to return 1. I hope you understood the problem statement. Now let's move on to the algorithm. Now, to understand the algorithm, we have taken the same example. So at first, we have to understand in which algorithm we should use to solve this problem. Basically, this problem can be solved using BFS, which is breadth first search. And suppose we are standing in a cell, and from this cell, I can go up, right, left, or down. That means in one move, we can reach any of the positions. So in the second move, we can reach up, right, left, or down. So it is the second level. Similarly, we can reach into the third level and so on. So BFS basically a level order traversal, and here we will use the BFS to solve this problem. Now let's write down the example. Initially, we are at this position, and from this, I can go up, I can go right, I can go left, or I can go down. So what are the valid moves? The valid moves is in one iteration, I can go up and left. Because we cannot go down or right, both of them are blocked with the walls. So this is our first level iteration. This is our first level iteration. Now, from this one, we are standing into a border. Okay. For this one, we can go into the 4 direction, up, down, left, and right. But the valid move is we can go left. And in the second iteration, we will reach to the border cell. Now, which one is the minimum? The minimum is this iteration. So here, we have to return 1 because in one move, I can reach to the border cell. So the basic intuition is currently we are at this position. Now, in one iteration, we can visit this cell. In second iteration, we can visit this cell and so on. So we have seen that by using only the one iteration, we can reach to the border. That's why we have to return 1. And this is how the BFS algorithm work into this problem. I hope you understood the problem statement as well as the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named nearest exist, which is a vector array and a vector of point. Initially, we are standing. Now we are taking a direction array with pairs by which we can move to the 4 of its direction. Now we are calculating the dimension of the maze, and initially we are assigning hash which is marked as a visited sign to the standing position, and we are initializing a queue and storing the current position into the queue to start the BFS, and initially the level is equal to 0. Now into this BFS, while the queue is not empty, we are calculating the size of the queue and increase the level. So for each of the cell in the each level, we are taking the front element of the queue into a variable p and removing it from the queue. Now for all of its 4 direction, we are calculating the new x and new y, which will be front element of the queues first plus direction array first, or front element of the queue second plus direction array second. And here, if the current or new x and y becomes out of bound, that means x is less than 0 or y less than 0 or x greater than or equal to n or y greater than or equal to m, or the current new coordinates x and y is not equal to dot, that means it is not empty cell, we have to simply continue. Otherwise, if the current x, y is standing in a maze, that means maze border, that means x is equal to 0 or y equal to 0 or x is equal to n minus 1 or y equal to n minus 1, we have to simply return level, because in this condition we have reached the boundary. After that, if none of these conditions becomes evaluated, we have to assign the hash sign to the current x and y position and insert the coordinate into the queue. Finally, if we did not able to return the level into this while loop or this BFS, we have to return -1. That means it is not possible for us to reach the boundary. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.